Welcome to our journey around the globe as we uncover some of the most mysterious natural phenomena that continue to baffle scientists and amaze travelers. Our planet, a vast and intricate tapestry of life and geology, holds secrets that whisper from the deepest oceans to the highest skies. These are not mere curiosities, but profound expressions of the Earth's dynamic processes, events that challenge our understanding and ignite our imagination. From fleeting celestial dances to ancient geological puzzles, each phenomenon offers a unique window into the forces that shape our world, reminding us that even in an age of unprecedented scientific advancement, there is still so much to discover, so much to marvel at. In this exploration, I shall guide you through spectacles that seem to defy logic, yet are entirely of this world. We will venture to the frigid poles to witness light born from solar winds and to tranquil bays that shimmer with living light. We will ponder stones that glide across desert floors as if by an unseen hand and gaze upon falls that weep crimson tears in the heart of Antarctica. These are places where the ordinary rules of nature appear to bend, creating landscapes and events that stir the soul and compel us to look closer, to question and to appreciate the sheer ingenuity of the natural world. Join me, Engis, as we embark on this quest to understand these extraordinary occurrences. Together we will delve into the science, the folklore, and the sheer beauty of these natural wonders. It is a journey that promises not only to educate, but to inspire a deeper connection with the remarkable planet we call home. Prepare to be astonished by the Earth's capacity for the unexpected, for the world is indeed full of marvels, patiently waiting for us to find them, to observe them, and to stand in awe of their intricate, often bewildering existence. Our first destination takes us to the high latitudes of our planet, to realms where the night sky becomes a canvas for one of nature's most breathtaking spectacles, the aurora borealis, or northern lights. Here, under the cloak of darkness, curtains of ethereal light shimmer and dance, painting the heavens with hues of green, pink, violet, and sometimes even a fiery red. It is a display so otherworldly, so profoundly beautiful that it has captivated human imagination for millennia, weaving itself into the fabric of ancient myths and modern science alike. To witness it is to feel a connection to the cosmos, a sense of the immense energies at play beyond our terrestrial confines. The origins of this celestial ballet lie not on Earth, but some 93 million miles away with our star, the Sun. The Sun continuously emits a stream of charged particles known as the solar wind. This cosmic breath travels across space, and upon reaching Earth, it encounters our planet's protective magnetic field, the magnetosphere. This invisible shield, generated by the Earth's molten iron core, deflects most of the solar wind, safeguarding life on the surface. However, near the magnetic poles, north and south, this shield is weaker, allowing some of these energetic particles to penetrate deeper into our atmosphere. It is here, in the upper reaches of the atmosphere, typically between 60 and 200 miles above the ground, that the magic truly begins. As these solar particles, primarily electrons and protons, collide with atoms and molecules of gas, predominantly oxygen and nitrogen, they transfer their energy. This excites the atmospheric atoms and molecules, causing them to become unstable. To return to their stable state, they release this excess energy in the form of photons, tiny packets of light. And it is this emission of countless photons that we perceive as the aurora's luminous glow. The mesmerizing array of colors observed in an auroral display is a direct consequence of the types of gas particles involved in these collisions and the altitude at which they occur. When energetic electrons strike oxygen atoms at higher altitudes, typically above 150 miles, they produce the rarer all-red auroras. More commonly, at altitudes around 60 to 150 miles, collisions with oxygen will emit the familiar vibrant green or yellowish-green light, the signature color of many auroral displays. These greens often form the lower fringes of the auroral curtains, shimmering with an almost supernatural intensity. Nitrogen molecules, on the other hand, contribute to the blues and purples, often seen at the lower edges of the luminous forms and in the very dynamic, fast-moving auroral displays. Sometimes when the solar activity is particularly intense, nitrogen can also produce a vivid pink or crimson hue. The sheer variety of colors, their subtle blending and rapid transformations make each auroral event a unique masterpiece, painted anew each time the solar winds caress our atmosphere. It is a dynamic process, ever-changing, ever fascinating. The shapes of the aurora are equally varied and captivating. They can appear as diffuse glows barely distinguishable from moonlit clouds, or as sharply defined arcs stretching across the horizon. More dramatically, they can manifest as flowing curtains, rippling ribbons, or pulsating rays that seem to shoot upwards towards the stars. These forms are dictated by the intricate interplay of the Earth's magnetic field lines and the incoming streams of solar particles, a complex dance of invisible forces made visible by light. For cultures living under these luminous skies, the aurora has long been a source of awe and interpretation. The Vikings of Norse mythology, for instance, believed the lights were the reflections from the shields of the Valkyries, warrior maidens who carried fallen heroes to Valhalla. Others saw them as the Bifrost Bridge, a shimmering pathway connecting Midgard, the realm of humans, to Asgard, the realm of the gods. These interpretations speak of a deep reverence for the power and mystery of the night sky. The Inuit peoples of North America and Greenland have diverse traditions associated with the aurora. Some believe the lights were the spirits of their ancestors playing a celestial game with a walrus skull, the light ebbing and flowing with their movements. Others saw them as torches held by spirits guiding newcomers to the afterlife. These beliefs often came with warnings. To whistle at the aurora might draw it closer, perhaps dangerously so, while disrespecting it could bring misfortune. Such stories highlight the profound impact these lights had on shaping their worldview. In Finland, a charming folk tale attributes the aurora, or revontule, to a magical Arctic fox running across the fells, its tail sweeping sparks into the sky. The Sami people, indigenous to the northern parts of Scandinavia and Russia, traditionally viewed the aurora with a mixture of respect and fear, sometimes associating it with omens, both good and ill. The lights were a powerful presence in their lives, a reminder of the forces that governed their harsh yet beautiful environment. Today, while science has unveiled the mechanisms behind the aurora, the sense of wonder remains undiminished. To stand beneath this celestial spectacle is to be humbled by the grandeur of the universe, to witness the invisible forces of our solar system made manifest in a silent, luminous symphony. It's a reminder that even in our modern, technologically advanced world, there are still natural wonders that can evoke a primal sense of awe, connecting us to the ancient rhythms of the cosmos and the enduring beauty of our planet's intricate systems. Our next journey takes us to the warmer climes, to secluded bays and coastlines where the waters themselves come alive with an ethereal glow after dusk. This is the realm of bioluminescence, a phenomenon where living organisms produce and emit light. Imagine gliding through the inky blackness of a tropical night, your passage marked by shimmering trails of blue-green light, every ripple, every splash igniting a silent, cold fire in the water. These bioluminescent bays are truly magical places, offering an experience that feels as if one has stepped into a dream. The secret behind this living light lies in a remarkable chemical reaction occurring within tiny, often microscopic organisms. The key ingredients are a light-emitting pigment called luciferin and an enzyme, luciferase. In the presence of oxygen, luciferase acts as a catalyst, causing luciferin to oxidize and release energy in the form of light. This is a highly efficient process, producing light with very little heat, a cold light that serves various purposes for the creatures that possess it, from attracting prey and deterring predators to communication and camouflage. In many of the world's most famous glowing bays, the primary architects of this nightly spectacle are single-celled organisms known as dinoflagellates. These are a type of phytoplankton, microscopic marine algae that drift with the current. Species such as or can exist in such high concentrations, sometimes millions in a single gallon of water, that their collective light creates a truly astonishing display. They are the unseen artists painting the night waters with their fleeting luminescence. The glow is typically triggered by mechanical disturbance. When the water containing these dinoflagellates is agitated by a swimming fish, a passing boat, the stroke of a paddle, or even a hand trailing through the water, the tiny organisms flash. This brief burst of light, usually lasting only a fraction of a second, is thought to be a defense mechanism, a burglar alarm effect, startling potential predators and perhaps attracting larger predators to prey on the initial threat. The cumulative effect of millions of these tiny flashes is what creates the mesmerizing, continuous glow we observe. One of the most renowned locations to witness this phenomenon is Mosquito Bay, or Bahia Bioluminescente, on the island of Vieques in Puerto Rico. Here, the unique geography of the bay, a narrow inlet restricting water flow, surrounded by protective mangrove forests that provide nutrients, creates perfect conditions for an incredibly high concentration of. The result is arguably the brightest bioluminescent bay in the world, where every movement in the water ignites a brilliant blue-green aura, transforming the mundane into the magical. Other locations around the globe also boast these luminous waters. Halong Bay in Vietnam, with its thousands of limestone casts and isles, offers moments where the ripples from a traditional junk boat can set the surrounding sea aglow. Similarly, the luminous lagoon in Jamaica provides nightly boat tours where visitors can swim in the warm, glowing waters, their bodies outlined in shimmering light. Each location may have its unique blend of contributing organisms and environmental factors, but the enchanting effect remains universally captivating. In Japan, Toyama Bay presents a different yet equally spectacular form of bioluminescence, primarily during the spring months. Here, the phenomenon is largely due to the firefly squid, or these small squid, about 3 inches long, possess photophores, light-producing organs, all over their bodies. During their spawning season, vast numbers migrate towards the shore and fishing nets bring them to the surface, creating an incredible spectacle of twinkling blue lights across the bay, a truly mesmerizing sight that has earned them the name Jewels of the Sea. The experience of being immersed in a bioluminescent bay is profoundly moving. As darkness falls and the stars begin to emerge, the water below mirrors the celestial display with its own living constellations. Kayaking through these waters, each paddle stroke leaves a swirling galaxy of light. Fish darting beneath the surface become fleeting comets. The silence of the night, punctuated only by the gentle lapping of water and perhaps the distant calls of nocturnal creatures, enhances the otherworldly atmosphere, making it a deeply personal and unforgettable encounter with nature's artistry. The delicate balance of these ecosystems is crucial for their survival. Pollution, coastal development, and changes in water salinity or temperature can have devastating effects on dinoflagellate populations, dimming these natural light shows. Conservation efforts are therefore paramount to protect these unique environments, ensuring that future generations can also witness the wonder of waters that glow in the dark, a testament to the subtle, intricate beauty hidden within the ocean's depths. Bioluminescence is not confined to these bays. It is a widespread phenomenon in the marine world, particularly in the deep sea, where sunlight cannot penetrate. Here it plays a vital role in the ecology of countless species, but it is in these accessible coastal bays that we, as surface dwellers, are granted a glimpse into this luminous realm, a reminder of the diverse and often surprising ways life has adapted and flourished on our blue planet. It is a silent, shimmering language of the sea, speaking of hidden wonders and the delicate interconnectedness of all living things. Chapter 3. Our journey now takes us to one of the most inhospitable yet strikingly beautiful landscapes on Earth, Death Valley, California. Within this arid expanse lies a remote, dry lake bed known as Racetrack Playa, home to a geological puzzle that has perplexed observers for decades, the phenomenon of the sailing stones. Here, rocks, some weighing hundreds of pounds, appear to move across the flat, cracked mud surface, leaving long, shallow trails behind them as evidence of their mysterious journeys. No human or animal intervention is apparent, leading to endless speculation. The setting itself is stark and dramatic. Racetrack Playa is a nearly flat, desiccated plain, about 3 miles long and a mile wide, surrounded by rugged mountains. The surface is composed of fine clay and silt, baked hard by the relentless desert sun. For most of the year, it is a realm of extreme heat and dryness. The stones themselves vary in size, from small pebbles to substantial boulders, originating from the Dolomite hills that flank the playa. Their trails, etched into the surface, can be straight, curved, or even sharply angled, sometimes paralleling each other, other times diverging or crossing. For many years, the mechanism behind their movement remained a profound enigma. How could these heavy stones traverse such a flat surface, seemingly of their own accord? Early theories abounded, ranging from the plausible to the highly imaginative. Some suggested powerful winds alone were responsible, pushing the rocks across a slick, muddy surface after rare rainfalls. Others proposed the involvement of dust devils or even more esoteric forces, given the valley's reputation for unusual occurrences. The lack of direct observation of the movement only deepened the mystery. The challenge lay in the fact that the movement is incredibly slow and infrequent, occurring perhaps only once every few years and often under specific harsh weather conditions that make direct observation difficult. Researchers would visit the playa, meticulously map the stones and their tracks, only to return later to find new trails or altered positions, with no clear evidence of the process itself. The stones kept their secrets well, moving silently when no one was watching, leaving only their enigmatic signatures behind. One persistent idea involved the formation of ice. It was hypothesized that after winter rains, a thin layer of water on the playa might freeze overnight. Perhaps the rocks, encased in or pushed by sheets of ice, could then be glided across the slick surface by the wind. This theory gained traction because it addressed the need for both reduced friction and a motive force. However, proving it required capturing the precise conditions and the movement in action, a feat that remained elusive for a very long time. The breakthrough finally came in the winter of 2013 to 2014, when a team of researchers, equipped with GPS units, time-lapse cameras, and a custom-built weather station, managed to document the phenomenon directly. Their findings, published in 2014, provided a remarkably elegant solution to this long-standing puzzle, confirming many aspects of the ice sheet hypothesis. It was a triumph of patient observation and scientific ingenuity in a challenging environment. The conditions required are quite specific. First, the playa must accumulate a shallow layer of water, deep enough to allow floating ice to form, but shallow enough that it freezes solid to the bottom in places, trapping the rocks. Then, a cold night is needed for a thin layer of ice, just a few millimeters thick, to form on the surface of this shallow pond. As the morning sun begins to warm the playa, this ice sheet starts to break up into large, thin panels. It is these expansive yet delicate sheets of ice, driven by light winds. Surprisingly, not gale-force winds, but gentle breezes of around 10 miles per hour, that act like sails, pushing the embedded or adjacent rocks before them. The movement is slow, almost imperceptible, typically only a few feet per minute. The rocks glide across the now muddy and slick surface beneath the ice, leaving their characteristic trails. The process can continue for minutes or even hours, with multiple rocks moving simultaneously. The researchers observed dozens of rocks moving in this manner, some traveling over 200 feet in a single event. The thin ice sheets, often tens of meters across, are strong enough to exert considerable force, yet fragile enough to shatter and reform, explaining the varied and sometimes complex patterns of the trails. The gentle winds provide the sustained push needed to overcome the inertia of even quite substantial stones, once the friction has been sufficiently reduced by the combination of mud and moving ice. Thus, the mystery of the sailing stones was largely solved, not by some supernatural force, but by a delicate interplay of water, ice, wind, and the unique geology of racetrack playa. It is a testament to how subtle environmental conditions occurring infrequently can produce seemingly inexplicable results. The solution, while scientific, does little to diminish the wonder of the place. Instead, it adds another layer of appreciation for the intricate processes that shape even the most desolate corners of our world, revealing a hidden dynamism in a landscape that often appears static and lifeless. Chapter 4. Our quest for natural mysteries now leads us to the coldest, driest, and most remote continent on Earth, Antarctica. Here, amidst the vast, icy wilderness of the McMurdo Dry Valleys, one of the few regions of Antarctica not covered by ice, a bizarre and striking phenomenon occurs. From the snout of the Taylor Glacier, a plume of vividly red water pours forth, staining the pristine white ice of Lake Bonny below. This is Blood Falls, a spectacle as eerie as its name suggests, and a puzzle that has intrigued scientists since its discovery in 1911. The sight is undeniably arresting. Against the stark backdrop of glacial ice and barren rock, the deep crimson cascade appears almost unnatural, like a wound bleeding out onto the frozen landscape. For early explorers, its origin was a complete mystery. Initial theories suggested that the color might be due to red algae, similar to those that cause red tides in oceanic waters. However, investigations soon revealed a far more ancient and geologically fascinating explanation for this sanguinary outflow. The source of blood falls is not a surface phenomenon, but rather a subglacial one. Trapped beneath the Taylor Glacier lies an ancient, hypersaline body of water, a brine lake that has been isolated from the atmosphere for perhaps millions of years. This subglacial reservoir is incredibly rich in iron, leached from the underlying bedrock over vast timescales. Crucially, this water is also anoxic, meaning it contains virtually no dissolved oxygen, a stark contrast to the oxygen-rich environments we are familiar with. When this iron-rich, anoxic brine from the subglacial lake eventually finds a fissure or pathway through the glacier and seeps out at the glacier's terminus, it encounters the oxygen in Earth's atmosphere for the first time in its long isolation. This exposure triggers a chemical reaction. The dissolved iron, specifically ferrous iron Fe2+, oxidizes, effectively rusting, to form ferric iron Fe3+ compounds, primarily iron hydroxides. It is these insoluble reddish-brown particles that give blood falls its distinctive, startling color. So, the blood is, in essence, rust. The continuous, slow ooze from the glacier ensures a steady supply of this iron-rich water, maintaining the crimson stain on the ice. The process is akin to how an iron nail left out in the rain will eventually rust and turn reddish-brown, but on a geological scale, driven by the slow, inexorable movement and melting of glacial ice, releasing ancient waters from their subterranean prison. But the story of blood falls does not end with its unusual chemistry. Perhaps even more remarkably, this trapped subglacial environment, devoid of light and oxygen and with salinity several times that of seawater, has been found to harbor a unique ecosystem of microorganisms. These are extremophiles, hardy microbes that have adapted to survive and thrive in conditions that would be lethal to most other forms of life. They represent a kind of life that exists entirely independently of sunlight, relying instead on chemosynthesis. These bacteria metabolize sulfate and ferric ions present in the brine, using them in a complex biochemical process to gain energy. The iron-rich outflow of blood falls provides a window into this hidden microbial world, a rare glimpse of an ecosystem that has likely persisted in isolation for immense periods, evolving in ways that are still being understood. The discovery of life in such an extreme environment has profound implications, not least for the field of astrobiology. If life can exist in such cold, dark, salty and anoxic conditions beneath an Antarctic glacier, it raises the tantalizing possibility that similar environments on other celestial bodies such as Mars or the icy moons of Jupiter and Saturn like Europa or Enceladus, which are thought to have subglacial oceans, could also potentially harbor microbial life. Blood falls, therefore, serves as a natural laboratory, a terrestrial analog for exploring the limits of life and the potential for its existence beyond Earth. The McMurdo Dry Valleys themselves are an extreme environment characterized by very low temperatures, minimal precipitation and powerful katabatic winds that scour the landscape free of snow and ice. The glaciers, like Taylor Glacier, are cold-based, meaning they are frozen to the ground beneath them, moving very slowly. This contributes to the long-term stability and isolation of subglacial water bodies, like the one feeding blood falls. The continued study of blood falls and its unique geochemistry and microbiology provides invaluable insights into Earth's past climates, glacial dynamics, and the resilience of life. It is a reminder that even in the most seemingly barren and inhospitable places on our planet, life can find a way, adapting in extraordinary fashions. The Crimson Cascade is more than just a geological curiosity. It is a flowing testament to the hidden, ancient, and surprisingly vibrant processes at work beneath the ice, a story written in water and iron. Chapter 5. Our final enigmatic phenomenon takes us to the coastline of New Zealand's South Island, specifically to Kikohe Beach near the small fishing town of Moeraki. Scattered along this stretch of sand like colossal marbles left by some playful giant are the Moeraki boulders. These are extraordinarily large, almost perfectly spherical or ovoid stones, some measuring up to 3 meters in diameter and weighing several tons. Their presence on this otherwise unremarkable beach has sparked curiosity and wonder for generations, inspiring both scientific inquiry and rich local folklore. These are not ordinary rocks worn smooth by the simple action of waves. The Meraki boulders are septarian concretions, geological formations that have taken millions of years to develop. They originated from ancient seafloor sediments laid down some 60 million years ago during the Paleocene epoch. At that time, this area was submerged beneath the ocean. The boulders formed within layers of mudstone as calcium carbonate gradually precipitated around a central nucleus, perhaps a fossil fragment, a piece of shell, or even a decaying piece of organic matter. This process of concretion is akin to how a pearl forms within an oyster, layer upon layer, but on a vastly grander scale and over geological timescales. As minerals, primarily calcite, cemented the surrounding mud and sand particles, these spherical masses slowly grew within the soft sediment. The remarkable sphericity of many of the boulders suggests that the minerals precipitated evenly in all directions from the central core, a slow and patient accretion in the quiet depths of the ancient seabed. Over millions of years, the sea levels changed and the land was uplifted. The softer mudstones surrounding these incredibly hard concretions began to erode due to the relentless action of coastal weathering, wind, rain, and the pounding surf. As the cliffs of mudstone retreated, the more resistant boulders were exhumed and left strewn across the beach, as if carefully placed there. Some are still partially embedded in the cliffs, while others lie solitary or in clusters on the sand washed by the tides. Many of the boulders exhibit a distinctive network of cracks on their surfaces, often radiating from the center or forming polygonal patterns. These are known as septaria, from the Latin word septum, meaning partition. These cracks are thought to have formed internally due to dehydration of the clay-rich core, shrinkage, or even seismic activity during their long burial. Later, these cracks were often filled with further deposits of calcite, sometimes yellow or brown, creating intricate patterns that resemble the shell of a giant tortoise, or a complex, natural mosaic. The local Maori people have their own captivating legends to explain the origin of these remarkable stones. According to tradition, the boulders are the remains of eel baskets, calabashes, gourds, and kumara, sweet potatoes, that washed ashore from the wreck of Arai Te Uru, a large legendary voyaging canoe. This great waka, or canoe, is said to have foundered near Shag Point, a nearby headland, while on a journey from the ancestral homeland of Hawaii. The petrified hull of the canoe is said to form a prominent nearby reef. These stories connect the boulders to the ancestral voyages that brought the Maori to Aotearoa, New Zealand, and imbue the landscape with deep cultural significance. The more elongated boulders are identified as the canoe's water gourds, while the perfectly spherical ones are its food baskets. The intricate septarian cracks are sometimes interpreted as the patterns of the woven baskets. These narratives transform the boulders from mere geological curiosities into tangible links with a rich ancestral past, sacred relics of a foundational journey. Visitors to Kekohe Beach are often struck by the almost artistic arrangement of the boulders, particularly at low tide when many are fully exposed. Some are perfectly smooth and round, while others are broken open, revealing their hollow interiors, or the crystalline calcite veins within. Their sheer size and unusual forms create a surreal, almost otherworldly landscape, a natural sculpture park carved by time and the elements. They invite contemplation, touch, and of course countless photographs. The ongoing process of erosion means that new boulders are continually being exposed from the receding cliffs, while those already on the beach are gradually worn down by the sea. It is a dynamic environment, a slow-motion unveiling and decay that has been occurring for millennia. The Meraki boulders serve as a powerful reminder of the immense timescales over which geological processes operate, shaping our coastlines and revealing the Earth's ancient history layer by layer. These spherical sentinels standing guard on Kekohe Beach are more than just rocks. They are time capsules, cultural touchstones, and objects of profound natural beauty. They challenge us to look beyond the immediate and consider the deep, slow rhythms of the Earth, the patient artistry of chemical precipitation, and the enduring power of stories to give meaning to the remarkable features of our world. They are a testament to the planet's capacity to create forms of astonishing symmetry and scale, leaving us to marvel at their silent, stony presence. Chapter 6. Our exploration of these 5 mysterious natural phenomena has taken us from the celestial dance of the aurora to the subterranean secrets of blood falls, from living lights in tropical bays to stones that sail across desert floors, and finally to the ancient spheres on a New Zealand beach. Each of these wonders, born from the intricate interplay of Earth's elemental forces and biological ingenuity, serves as a profound testament to the planet's enduring capacity to surprise and inspire. They remind us that our world is a place of deep complexity and breathtaking beauty, with mysteries still waiting to be unraveled. These phenomena are not isolated curiosities, but windows into the grand, interconnected systems that govern our planet. The scientific understanding we gain from studying them enriches our appreciation, yet it seldom dispels the awe they evoke. Indeed, the more we learn, the more we realize the depth of nature's creativity and the delicate balance that sustains such marvels. It is this sense of wonder, this unceasing curiosity that drives us to explore, to question, and to seek a deeper understanding of the Earth and our place within its magnificent story. And thanks for joining us on this incredible journey. Don't forget to like, share, and subscribe for more fascinating insights into our world's wonders. As we continue to observe and learn, we find that the map of discovery is ever unfolding, revealing new questions and fresh marvels. The Earth still holds countless secrets, and the adventure of understanding them is one of humanity's most noble and rewarding pursuits. May we always approach our planet with the reverence and curiosity it so richly deserves.